we're going to start our unit on power functions. So power functions, or polynomials, are whenever you have x raised to any power. So this power is called the degree of the function, and we always have a number that's an integer greater than 0, greater than or equal to 0. So we're never going to have a decimal or a negative number during this unit. So if our power is 1, so x to the power of 1, we know what this graph is. This is a linear graph. Whereas if it's x to the power of 2, this is another parent function we already know, it's quadratic. So today we're going to look at some other power functions. Let's start off by making a generalization about any power function where your power is even. It's going to be a graph that looks something like this, where if the power is even, your function is also even because it's symmetric across the y-axis. And the n behavior, which means as you go all the way to the left, so as x approaches negative infinity, this is when you move all the way to the left, or as x approaches all the way to the right, positive infinity, if you go in either direction, your y values are both going up, which means it's going towards positive infinity. Now let's look at odd functions. So if your exponent, the power, is odd, then your graph is also going to be odd, because now it's symmetric across the origin. So this one was y-axis symmetry, and this is origin symmetry, which we learned from a previous unit. So this one's a little bit different when we look at the n behavior. As x approaches negative infinity, which is to the left, our y value is now going down. So our y value is also approaching negative infinity. Whereas as x approaches positive infinity, so as x goes to the right, your y value is now going up, so y is approaching positive infinity. So these are all the different types of functions. So from x to the third, x to the fifth, x to the seventh, this is x squared, x to the fourth, x to the sixth. So they're all similar looking. They either both go towards infinity, or one goes towards negative infinity, one goes towards positive infinity. Okay, let's look at the two specific graphs we're going to be focusing on today, which are the cubic function and then the quartic function. So the cubic function is x cubed. So like before, we're always going to start with 0, 0. 1 cubed still gives us 1. 2 cubed gives us 8. So this is going to be on one side of a function. Negative 1 cubed, when you have negative 1 times negative 1 times negative 1, is going to give us negative 1. And then negative 2 cubed is going to give us negative 8. So this is our parent function. Let's draw this on our graph. So 0, 0, 1, 1, 2, 8, and then negative 1, negative 1, negative 2, negative 8. So notice how in this direction, to the left it's going down, to the right it's going up. That is an odd function. So our domain from left to right is all real numbers. Our range from bottom to top is also all real numbers. And like we just talked about, this is an odd function because it's symmetric across the origin. It's also one-to-one because it passes both the horizontal and the vertical line test. It's increasing the entire way, so from negative infinity to infinity. And there is an intercept at 0, 0. So those are the characteristics of the cubic parent function. The other parent function we're going to look at today is the quartic parent function, which is x to the fourth. So again, let's start at 0, 0. 1 to the fourth power is still 1. 2 to the fourth power is 16. And now if we go the other direction, so we go to negative 1. Negative 1 to the fourth power, because it's an even exponent, cancels out our negative. It actually leaves positive 1. Negative 2 is going to leave us with positive 16. So let's graph our parent function. We have 0, 0, 1, 1. And 2, 16 is going to be way off the graph. So even though we can't see it, we're going to draw a line that goes all the way up. Be careful that this line doesn't cross the 2, because at 2 it should be all the way up at 16, right? So it shouldn't cross anywhere over there, because it should only cross the 2 when it hits 16. This direction is also negative 1, 1, and negative 2, 16. Again, draw a line going up, being careful not to cross the 2 because it shouldn't hit this line until it gets up to 16. So this one, as you can tell, is an even function. both to the left and to the right, it's going to go up. Okay, so our domain is still all real numbers, negative infinity to infinity. Our range this time, there's a low point. It's 0, so it's going from 0 to infinity. As we discussed, this should not be here, oops. As we discussed characteristics, it's an even function because it's symmetric across the y-axis. It's not one-to-one. There is a minimum of 0 at x is equal to 0 because this is your minimum point right there, the vertex. We know it's decreasing from negative infinity to 0 and also increasing from 0 to infinity. So decreasing from here to here, increasing from here to here. And there's also an intercept at, again, 0, 0. So these are the characteristics of your quartic parent function. So these are the two parent functions we are going to be transforming today. Let's take a look at a couple quick examples. Let's flip the page. So for number 1, the first thing you need to notice is that this is a cubic function because of that x cubed. So we know our parent function is 0, 0, 1, 1, 2, 8 in both directions. Okay, so this is my parent function. It looks like this. What has happened to this transformation? The -3 on the inside means I've moved to the right 3. -2 on the inside tells me I've moved down, or on the outside means I moved down 2. So this tells me all of my points have just been moved. Right 3, 1, 2, 3, down 2. So this is my new 0, 0, my new origin, and all my points should look like they've moved. Right 3, down 2, right 3, down 2. So this is this side of it. Right 3, down 2, right 3, down 2. So this is my final function right there. My domain is all real numbers. My range is also all real numbers. Cool, done with number 1. Okay, let's look at number 2. Now my parent function here is x to the 4th power. So my parent function is 0, 0, 1, 1, and then way off the graph, right? So it was 0, 0, 1, 1, 2, 16, and then in the other direction as well. So what has happened here? So first of all, this negative tells me that it has been reflected, the negative y, across the x-axis. So x-axis reflection. The 1/2 is being multiplied by y, so it's a vertical compression by 1/2. And then I also have this +4, which is just up 4, because they're all outside of my parentheses. There's nothing inside parentheses here, because there are no parentheses. Okay, so the first thing we're going to do is flip this across the x-axis, so now it's going to be opening down instead of up. I want to multiply all my y's by 1/2. So it's -1, 1, -2, 16. If I multiply all of my y's by 1/2, this now becomes -2, 8, -1, 1/2, 0, 0, 1, 1/2, and 2, 8. All right, so I multiplied all my y's by 1/2. So let's graph this. I have -2, 8, -1, 1/2, 0, 0, 1, 1/2, and 2, 8. So right now here are my points. And all I need to do now is shift them all up 4. So I'm going to move all of them up 4. This one goes 1, 2, 3, 4. The one that's at a half goes up 1, 2, 3, 4. So it's still about 1/2 below this one. And this one also goes 1, 2, 3, 4. 1, 2, 3, 4. I'm going to connect all my points. And this is what my final function looks like. This is f of x. My domain is all real numbers. My range, however, because it's starting at the lowest point, is the arrow going on forever, -infinity, up until highest point, 4, bracket, because it's included. Finally, we're going to look at how to write equations for the following functions. So the first thing you got to do with these is to figure out, is it cubic or is it quartic? So looking at this, it's clearly a cubic function, right, because it's going up in one direction, down the other one. We know our parent function is 0, 0, 1, 1, 2, 8. So the first thing we got to do is figure out, okay, how has this been shifted? So it's moved, this point right here, the center point has moved 1, 2, 3 to the left, which means inside of my parentheses I want to have an x plus 3, right, because it's moved 3 to the left. Once it's moved 3 to the left, what else has happened here? Notice that it's going in the other direction as what it would normally go in, right? So normally it goes up on the right, down on the left, but it's clearly been flipped. It's been flipped across the x-axis, right? Yeah. It's been flipped across the x-axis because now this one has been flipped so it's pointing down, this one's flipped so it's been pointing up. And so, if it's been flipped across the x-axis, it's an x-axis reflection, which means it's a negative y. We could put a negative outside of my equation. And that's all that's happened over here, because if I flip it, this is now 1, 1, 2, 8. Everything else looks the same. 1, 1, 2, 8. So this is my function right here. Negative x plus 3 to the third power. Okay, for my next one right here, this number 4, this is clearly a quartic function now. So this is to the fourth power because it's been going, they're both going up. So the first thing that's happened here is that it has shifted from its starting point. So we know that the starting point is supposed to be 0, 0, 1, 1, 2, 16, which is way off our graph. Same thing in this direction. So the first thing that's happened is that it's shifted 1, 2, 3, 4, 5 down. So if you know it's been moved down, that's going to be outside our parentheses. We're going to have a minus 5 on the outside. Now let's look at our points. So from here, our parent function is supposed to go 1 over 1 up, because it's 0, 0, 1, 1, 2, 16. Instead, it's going 0, 0, look at this first point, 1 over 2 up. So what has happened to get from this one to this one? Our y values have been multiplied by 2. So if our y values have been multiplied by 2, that 2 is going to go on the outside. And nothing else is happening to this function, so all we have left is this x on the inside. Nothing else is going to go inside. So we don't even really need those parentheses.